Hey, everybody. It is the 7th of January, 2025, and this is the first meeting of Aiken PBL from Gimbalabs and Friends. We get together on Tuesdays at 14:30 UTC to work through the Aiken PBL course that Sidan and Gimbalabs have been building together with Catalyst funding. Hinson sends his love. He's on vacation for another couple days, but he will be back and delivering next week's lecture. Our calendar has us looking at Module 201 today, but there's a lot to cover there, and I don't know if we'll get through all of it. So, preliminarily, our plan is to look at 201 today and 202 next week. But at the end of this session, we can update those plans if we don't cover everything in 201, because although it's only 4 lessons, it's a really big and important one. So what I'm going to do here is share screen first. And we've got the course. And before I forget, let's, I just want to pull up the chat to pull up the links that Nanya shared before we went live. And let's actually start with this question. I think this is helpful. So I've got a question about the libraries used for Aiken. Yeah, I know. Um, just keeping you anonymous, Nanya, if you want to be. But you spoke to K-Tors about the libraries. He said that the STD, the standard library, is different than what you see in control flow right here. So let's take a minute to just poke around at this. Um, if I look at the standard library, right, here is the documentation for a lot of the stuff that I want to use the term built in, but the reason I kind of can't is that there's another library called built in, right? So the standard library, what does the standard library provide? It provides this essential Aiken functionality, primitive types, some other stuff that you'll be familiar with soon if you aren't yet, just by starting to work with Aiken. And then there's this on-chain Cardano stuff, right? A bunch of stuff. And we've looked at some of these docs. We're going to continue to look at these docs. But just to give us a chance to distinguish between a few things, the first thing I want you to notice is that up here in the top corner, we we have Prelude, built-ins, and standard library. Okay. I'm looking at standard library right now, but if I click on Prelude, it's going to go over there. And you can see now we're in Prelude and it's got this stuff, or there's built-ins, and now we're over here, and it supplies a different set of functions. The question is, how does the dev know which library to use? Um, and the the most realistic answer to that question, honestly, is simply by practice. This is one of those things that once you get hands-on with this stuff for a little while, you'll have your own definition for what Prelude, built-ins, and standard library are. Whatever anybody says to you or whatever you can read in the docs is not as valuable as just having your own picture of what these things are. So I can give you my picture of that for now, right? What is the standard library? Well, it's the specific Aiken and Cardano stuff, right? This is specific to the Aiken language, specific to Cardano interactions. These are the building blocks of a Web3 app in Aiken. What's the prelude? These are kind of the lower level stuff. Before we can even get started building, we have to define some basic things like Boolean, data, int, list, right? You can see that right here. So prelude, just like the prelude to a book, is the stuff that comes before, the prerequisite stuff. And then built-ins are just all these helper functions that do a lot of really useful stuff. But as you can see right here, none of them are necessarily limited to Cardano, right? Addition functions, byte array functions, comparison functions. And a lot of these are helpful for the kinds of types like byte arrays that we have to use when we write on-chain code. But there's nothing that limits the usefulness of this to on-chain code, right? You can see that a lot of these prelude functions reference what minimum version of Plutus they're compatible with. And you can see where certain features were added, like V2. I bet we could even find a V3 here, right? Byte array to integer. That wasn't possible until Plutus V3, right? So we have a prelude with types that we just can't build anything without defining these things. We have built-ins that are helpful functions that are optimized for writing Aiken code, but in scope, not necessarily limited to it. And then finally, we got the standard library, which gives us the stuff that you're really going to be using when you're writing validators and interactions. How does that feel, and what questions do you still have if I kind of give an overview that way?
I mean, I think you did a great job explaining it. And yeah, I took notes on it. So, I mean, I hope anybody else that watches this will also get your information and take note.
And this is again, right? This gives us a chance to, by practicing, really get to the heart of why these things exist. Now, if I look at control flow, what's nice about this is that each of these documents are searchable, right? So if I see something like, yeah, I mean, so defining let and if and else, right? That I would assume that's the prelude, not always identity fluid. But that's kind of yeah. I would have to do a little bit of reading to understand exactly where in the Aiken code base, like if, else, and these really low level things are defined. Like I don't see documentation for if right here. I could search for it. Oh, here, if then else. But yeah, that's a different function. That's a function that combines these things. But did you see what just happened there? I was actually in the prelude, but by searching, I got to this built-in function. That doesn't happen over to standard library, I don't think. So like, let me look at credential. If I'm in prelude and I search for credential, it says no results found. So searching is going to work across Prelude and built-ins in common. But if I search for something here and I don't find it, then I can toggle over to standard library. I can search for credential, and obviously I see a bunch of things there. So search is a good friend, and practice is how we build mental models, and that's how this course is constructed. So with that in mind, and we'll keep going back to these docs. We're gonna keep going. We're gonna keep trying to link you guys out to these documents at opportune times while we're going through the course. But let's pick up where we left off. What? Oops, that's another word that starts with A on Domio, but we want Aiken. So far we have set up our development environments and seen a little bit about writing tests. We went deeper into writing tests by writing just some really simple validators and seeing how tests might apply to those. And then last session, critically, we started talking about mock transactions. And the videos for all of these, 101, 102, and 103, are on YouTube. The Gimbalabs YouTube, we have a playlist for it. You can find all of those things. Today, we're going to really jump into writing smart contracts with actual validation logic for the first time. And I misspoke at the start of this session. I thought there were only 4 lessons here. No, this is a really big one because one by one, we're going to go through some essential concepts of writing a validator in any on-chain language. Okay. So the idea of redeemers, datums, parameters, inputs, signatures, time, and then combining inputs and outputs, all of these concepts, we're going to look at these in the Aiken sense starting right now, but these apply to every on-chain language on Cardano, whether you're writing in Plutus, whether you're writing in Helios or PluTS or Option or any number of other languages that keep emerging. These concepts are common to all of it. And if you learn about Redeemer and Datum in one language like Aiken, what you learn here will be valuable if you ever try to learn Plutus itself. Any questions about that before we jump in? Okay. So, introduction. These are the learning targets. We just saw these on the screen. We're going to write a validator that checks against the value of a redeemer. We're going to write another one that checks against the value of datum. By doing this, you're going to see some common patterns between each example. And when you see those common patterns, I hope that really helps you see the connections between how all these building blocks fit together. We'll take a validator and we'll add some parameters to it. The way Aiken handles validator parameters is a little bit different than how Plutus does. So this will be nice for everybody to take a look at. We can then look at some specific things in lessons 4 through 7, where we create validation logic that checks against different specifics. What's exciting here is that once you know these 7 building blocks, you'll be ready to start being creative in designing your own on-chain logic. Okay, this is enough to start hacking and tinkering and seeing how things work once you know these basics, right? These, once again, are the essentials. No matter what language you're writing in, redeemers, datum, parameters, and the context of a given transaction are going to be present in all of those in any on-chain language. We're going to follow a pattern throughout each of these lessons, just like we started to establish earlier in the course. An example will be provided, and more as we go through, our goal is to leave it to you to explore a little bit more deeply, right? This is how Gimbalabs is built. This is core to our educational philosophy. We want to give you just enough to go explore on your own. Why? Because when you do, you're going to encounter questions, and then you can bring those questions back here, just like Scott did today. Okay. So what I hope is that you'll leave this session, you'll go try some things, you'll go break some things, and if you get stuck, please do bring those questions to this session next week. Let's jump in. So, lesson 201.1, redeemers. You've probably heard this word before if you've been around Cardano. What does a redeemer do? What does it mean, right? Well, a few things to get us started. In any validator, you can define custom types for datum and redeemer, right? You can use any of the built-in types that we see in the prelude, right? Int, well, not any. I shouldn't say any of these types. Um, but and we'll talk more about the specifics here, right? But like a redeemer or a datum, it could just be a simple Boolean value. It could be an int value or a byte string. It could be a list. Most often, to build useful logic, it'll be some custom type that you define in order to achieve whatever you're setting out to do. Okay. What we're going to look at here is a certain type of redeemer that's more like an enumerated type. Okay, so if you've ever used a programming language that has like an enum indicator, this might be familiar to you. If you're not familiar with it, the concept here is that um, think for example, let's start with a Boolean, right? Like the value of Boolean is true or false, right? Now, if I write the word true on the screen, yes, I am writing a string. So you could claim that like Boolean looks like a string, but it's definitely not a string because it can only have the value true or false. And different programming languages might have different conventions. Is it a capital T or is it a lowercase t? A capital F or a lowercase f? All of that is just defined at the language level, but the options for what a Boolean can be, still there's only two of them, right? True, false, 0, 1, T, F, yes, no. Okay. Now it's possible to define your own similar types. For example, maybe I'm building an application about pets and I don't want to allow people to just write any pet off the top of their head. I only want my application to work for cats, dogs, and fish, right? So what I can do is instead of defining a type that says pet must be a string, I can say pet must be cat, dog, or fish. And when I do that, that's the idea of an enumerated type. Okay. I'm setting a finite list of values for what this variable can be. So you can read through this over here, but this is a really helpful concept because redeemer is often used as something like an enumerated type. Why is this valuable? Well, ever since Plutus was launched, developers have come up with different ways of just like describing in plain language what a redeemer does. And there's a few really fun ways to describe it. But one of my favorites is this. The redeemer, which is specified at the time a transaction is built, right? Again, the redeemer is specified at the time a transaction is built. The redeemer often serves as a statement of intent by the party building the transaction. Look at this case right here, right? Whoever builds a transaction to interact with this validator, and now let's jump over to VS Code because that's too small on the screen to be helpful. I'm going to open up Visual Studio Code. I'm going to zoom in a little bit. This is the repo that's live on Gimbalabs GitHub. You can pull it down, and if you missed how to do that, just go back to lesson, it's 101.1 at the start of the course. Um, but let's look here at the validators for module 201, and lesson one is about Redeemer. So this is where we are defining our custom Redeemer type. And look at these values. This is enumerated. These are not strings. These are just values for what the Redeemer can be. And what is my intention as a user when I interact with this validator? Well, my intention in this case could be success or failure. I intend for this redeemer or this validator to be successful in one way or another way, or I intend for this validator to fail in one way, another way, another way, or in more ways. Okay. And we're just playing right here, where our goal is just to show you that these strings can be whatever you want. And once they're defined, they're just labels for the actions that a user can take. Oops, I didn't reset my Aiken language server. So let me pause right there for just a second. Everybody good with this concept so far, or do you have questions yet?
Yeah.
So a transaction is where this thing is specified by a user. And it's helpful, I've found, to think about other places where transactions happen, like like a corner deli, right? I often walk into the corner deli to make a transaction. Now, when I walk into the deli, I usually don't walk in the door and announce, I want to buy a coffee, right? But I do have an intention. I do have a reason for being there. And my reason for being in the deli is it's going to be different my experience with my transaction is going to be different depending on my intention. If I walk in just wanting a coffee, my interaction with the people there are going to be different than if I walked in wanting to rob the place, right? Different intentions, different transactions. And that's really what this allows us to do right here. We can create a set of intentions so that when somebody interacts with your application, they state their intention, and then the validation logic proceeds accordingly. Now, this one is pretty straightforward. For the success cases, what do we want the validator to do? We want it to be true. If the statement of intent, if the redeemer says success redeemer or another success case, sure, let's validate. But if the statement of intention is to fail, which is all the other cases, here's our wild card, then the validator will fail. So far, so good?
Wild card is that underscore?
That's right. Yeah. So basically, right here in this is the logic. This is the business logic of our redeemer. When the value of redeemer is this, right, this one, succeed.
Right.
When it's this one, succeed. Now, could I just write each of these? We could just grab all of these and put them here. And then for each one, we could say false. But hopefully you can see right away how it's more efficient. So right here, and actually this is fine logic, right? Even if I did these 4 lines, I would actually still want to leave. I need to set up my LSP. I would still leave the wild card here just in case some other value for the redeemer tried to sneak through. Right? It's still a
Sure.
good idea to keep this, but I can leave these lines out as well just because it's more efficient. And the fewer lines of code, the fewer characters in your on-chain code, the cheaper it's going to be to execute this validator. So actually, by leaving these 4 lines out, you'll be saving money. So that's another reason why it's a good idea.
Cool.
So very basic use of Redeemer right here. I hope this is giving you a basic picture, and I hope that concept of intention is helpful. There are other ways to explain what Redeemer is. Some people describe it as like the key that you're sticking into a lock. Okay. And you'll hear other ones. We'll also get into even more complicated cases where we have more than just an enumerated type in the Redeemer. But for now, this is a really nice place for us to start. So if this is our validator, remember what we've been doing in this course. We've been running tests on our validators. We're not going to try to use this thing on chain. All we want to do is check that the logic works the way we intended. So let's read these tests. This will be a little review. It's been a couple weeks since we've done this. But reading through the first test, this says let redeemer have this value. And then we're going to run, what does it say? Check redeemer dot spend. Okay, where is check redeemer coming from? Okay, check redeemer is the name of the validator we wrote in the first place. Okay. And it says dot spend because the endpoint we're hitting in this validator is the spend endpoint. No other purpose is defined here, right? Else we fail. So if I tried to write check redeemer dot mint, remember that would fail.
Mhm.
Now this spending endpoint takes 1, 2, 3, and 4 parameters. Here they are: datum, redeemer, input, transaction. Most of these don't matter to us. There's an underscore in front of datum, input, and TX. And that means that the validator can safely ignore those values. We're not validating against them. We're only looking at redeemer. There's no underscore in front of redeemer, of course, because that is at the core of our validation logic right here. So when we test this thing, what are we going to do? Well, we're just going to pass none for datum. More on that in just a moment. We're going to pass redeemer as redeemer, which is defined right here. That's very good. We're going to pass a mock ref UTXO as our output reference. And if I don't know where that came from, I could control F to search, or I can go up to the top. Oh, there it is. It's one of my imports. Remember, we're importing this from the mocktail library from Sedan Labs, who in the last lesson, we looked at all of these helpful utilities they're providing for us. And then finally, for our transaction itself, we're passing the placeholder transaction, which is imported from Cardano transaction. Let's go take a quick look at the documentation just to see it in context. I want to find none in the documentation, and I just want to make sure we review placeholder in the documentation. And just jump in with questions as I switch screens if anybody's thinking about anything.
Yeah, I was just thinking, these enumeration types, the values that are passed, are they not like variables? Because right now the success, the types that are passed, we are checking them if they are true or not. So where are we writing or specifying the logics of these types?
I'm going to show you that when we run the test. Such a good question. And hey, Emmanuel, Happy New Year.
Yeah, same here, man.
Hey, man. Yeah,
Yeah.
let's look at that question by let's do a little bit of hacking to answer your question in just a minute. Before we do, just going to review two things in the docs. Okay, so first of all, let's do placeholder first. I don't feel like clicking around and looking for placeholder, so I'm just going to search for it. Oh, placeholder, no results found. Okay, so it's not in Prelude. Let me try standard library and search for the same thing. And of course, there it is, right? Now, another answer to the question we started with. How do I know where to look in the docs? Suppose you don't want to search, or you want to be more efficient finding this thing. Well, check it out. Let me go back to the source code for just a moment. Where did placeholder come from? Well, it was imported from right here, Cardano transaction. Oops, I didn't change my screen. I'm sorry.
Yeah, I was about to say, okay, here we go.
Sorry. Try that one more time. Back to the source code. There it is. Did that work?
Yeah.
All right. Where did placeholder come from? It was imported from Cardano/transaction. So another answer to the question we started with, how do I know where to look? One of the best ways to answer this question is to inspect the import statements. And if I'm importing something and using it, I know that where it's imported from is going to help me find it in the docs. Cardano transaction. Where is Cardano transaction? Well, this one, I just have to know this. And after a few rounds of practice, you will know this. Cardano is in the standard library. And inside of it is, of course, transaction. There it is. This matches my import statement. And of course, on this page now, if I scroll or if I search, eventually I will find, there it is, placeholder. Okay. Now, we did a deep dive into placeholder in a previous lesson. My goal right now is just to review where you can find this in the docs. Placeholder is a transaction. That's also in the docs. And just keep in mind that anytime we're talking transactions in Aiken, you have access to all of this. The placeholder is the version of the transaction that has null-ish values. Okay. The other thing we wanted to look for in the documentation was this none word. Okay. We say that the value of datum is going to be none. Why is that possible? Because we're using the idea of option. Aiken option. Looks like option is defined here, readily available. So I searched for option. It says, note that the option type and its constructors are available. Ooh, they are part of the prelude. So I didn't know where this was, but the documentation tells me. This is why we love the Aiken team. They answer our questions. They are part of the prelude module. Okay, now I know that if I want to find out about option, I have to look in prelude. Let's do it. Let me search for option. Here we go. Okay. What are the possible values of option? Either some data or there it is, none. The reason I'm showing you this is because this concept right here is it was certainly new to me when I came to functional programming, first via Haskell and Plutus, and now via Aiken. I wasn't really familiar with a concept like this from the languages that I knew, right? But this essentially allows us to say, hey, maybe there's data here. And the word maybe is the word you'll see in Haskell to express a similar idea. All right. Maybe there's data. We don't know. Okay. Optional. And if it exists, we're going to have some data. And if it doesn't, we're just going to say none. So let's go back to the source code one more time and look at the type of datum. We said it was, there it is, optional. Optionally, we will pass some data. By the way, data is also defined in Prelude. You can look that up. And when we say that datum is optionally data, this means, of course, that one of its values can just be none. And that's why we have the word none right here. So we're saying, let's test the spending redeemer with no data, don't worry about it, with this redeemer, with a mock output reference as our input and a placeholder transaction. That's enough to see if this logic works. So now we get to answer Emmanuel's question. Let's actually run this test and let's hack around with it a little bit. Okay, so the first thing I'm going to do is just run Aiken check. Whoops. Oh, I need to close and come. Hold on one second. I just installed Aiken while VS Code was open. For anybody following along, I like at the new year just to wipe my computers completely and pretend I have a brand new one. So that's why that just failed. So let me fix this.
It's a teaching moment for sure.
Let's see.
Harsha, what do you think if you wiped your computer every New Year's?
Then I wouldn't have a computer because I don't know how to wipe it.
Let's try it again. Okay, I just opened this again, so my updates should be in place. Aiken check. Come on. Let's do this. Well, in any case, I'm not going to go too deep into that right now. Oops. Okay, VS Code. Oh, that's one. All right, now we can go into here and let's try it one more time.
So Aiken checks for a TOML file. I just got that because I got a warning.
Yeah, exactly. You can only run it from the like basically the parent directory of an Aiken project, which would be the one with the TOML file. And remember, this is the file right here that just defines some metadata about our project, a name, a version, which version of Aiken to use, which version of Plutus that corresponds to, license, your description. This is arbitrary, right? And then any dependencies. Okay, so I just ran Aiken check at the top level of the project, and of course it ran all of the checks in the whole project. I don't actually want that, so remember that instead of writing just Aiken check in general, we also have the option of writing Aiken check -m and then some string that we want to match. I just want to match, how about, can I do L1 Redeemer? Let's find out. The name of this test is right here. Let's just do MD201. MD201. Now it still ran 20 checks, but all of them are the ones within module 201. That's pretty good. But we can get even more specific than that. Let's do MD201 underscore L1 so that we only see the checks for this lesson. MD201 L1. There, that's kind of manageable to look at. Okay. So far, so good.
Nice, yeah.
Now, both of these pass. First of all, let's switch to a failing case. Let me use fail redeemer instead for this first test. Let's save it and let's just run the same checks again. And now you see the first test is failing. Good. It should. Let's do a different thing where we try a string that's not actually one of these values. My own personal despair. All right, what's going to happen if I run that? Okay, so this gives us a different error, not just a test, but an actual, yeah, Aiken doesn't know about my own personal despair. That's an unknown variable, right? We didn't include that in things. So we get a message here about how Aiken types are working. Okay, any questions about that? You see how this is a different, this is like a compilation error. We're not even getting to a testing error. So far, so good right there.
Love it. And great docs. Look at that.
Yeah,
Look at
this is
the
another wonderful thing. I mean, these messages we get from Aiken are I find them to be really helpful. Harsha, what do you think?
So I have a small noob question. So you defined the types and then you said if the type is true, then the transaction happens. But how is that logic happening? How does the computer know if the type that you defined is true or not?
Yes. Okay. And I think that was similar to Emmanuel's question. So now we're finally ready to get to that question, right? Now, let me just go back here for just a second. Fail redeemer. We know as humans that fail redeemer sounds like a failure case. But there's nothing inherent to the way we write this string that says it must be. Where is this defined as a failure case? Right here. What are the values of redeemer that will return true? We say success redeemer is going to be true, and we say another success case is going to be true. But there's nothing stopping us from saying that fail redeemer can also return true. To my human eyes, that doesn't make logical sense, of course. But in terms of Aiken, watch, if I now say that this redeemer is going to be true when because fail redeemer is going to allow the validator to succeed. If I run these tests once again, of course they both pass because I included this now as a success case in my validator. Similarly, if I removed success redeemer from this list and I go back down here and I say, yeah, let's check that success redeemer is a successful case, and I run these tests again, it fails. Because once again, there's nothing built in about the human readable language that says this must be a success case. Harsha and Emmanuel, does that help answer your question? And let me know, do you still have clarifying questions about that?
Uh, uh, I think I am clear. So my understanding is that the computer doesn't necessarily check success redeemer is true or not. It just, we already defined that if success redeemer is there, it is true. So is that correct?
We wrote explicitly inside of our validator that when the redeemer has these values, it should validate successfully, right? Remember what the word true means. It means, yes, allow somebody to unlock this UTXO, right? And so whatever we say right here, this is the business logic of our validator. Emmanuel, yeah, what do you think?
Yeah, I'm getting it clear now that we are defining the enum types to be to always return Boolean values, either true or false. But this type of redeemer right now, can we also define I know you said we can give it like arbitrary types to return any types of values. So this when redeemer is, can we like give it another type to return another type, like maybe list, as you said?
Yes. Yes. So for example, you can define a redeemer type that includes a list instead of just these enumerated values here. It could have like, and this is like a record type or like a data structure that you might build in TypeScript, right? That has its own sub fields inside. I could add a field inside of this type that defines some list, and then I could write validation logic that checks whether or not that list is of a certain length, or I could check whether or not that list includes a certain value. I could check whether or not that list includes some value that's specified in the datum, for example. The sky's the limit here. And one by one, we are going to start looking at those examples. But yes, like that's the idea. You can be as creative as you want here within the bounds of what Aiken allows, right? Using the building blocks Aiken provides to build your own types. Now, this test down here, notice the second test is passing, even though it says let Redeemer be another way to fail. Why is that? It's because of this exclamation point right here. That's the not sign. Okay. So what is this test testing? It's testing not this. And what's the value of not false? Oh, true. Okay. So we say check redeemer spend with a redeemer that says another way to fail. We expect that to return false. So this test should succeed as long as this returns false. Does that make sense?
Yeah.
Little bit of double negation,
Yeah,
mental
yeah.
gymnastics here. But
It doesn't not make sense. Hmm?
does
Okay.
this not make sense?
Oh, man.
Okay. So I encourage you to play with these tests, right? Like play around with these, add values for the redeemer, try different tests, and then before you run them, predict if they're going to return fail or pass, or maybe even predict if they're going to break the compiler like we just saw when I added my own arbitrary value here. Okay. And that's a really nice way just to really to feel things out. Any questions before we move on to datum?
All right, Scott's got a question.
Yeah.
It's more on the output of the test, right? Where it says mem, it's got your mem and then some the numbers there and then the CPU.
Yes.
What exactly are those um signifying?
Yeah, good question.
Excellent. Great question. Yeah, these are used directly in the calculation of the transaction fee when this thing is used on chain. Okay. So yeah, so obviously when is a validator used? Oh, in transactions. That's the only purpose, right? A validator has no value other than its ability to gate a transaction, right? And therefore, we want to know, well, how expensive is it going to be to run my transaction? And there's a whole bunch of Cardano protocol parameters that are used to determine the value of that or the fee for that transaction. But these two right here are the ones that come directly from your validator itself. And so this is just giving you a picture as a developer. All right, how expensive is it going to be to use this thing? Okay. Mem is used pretty consistently. CPU right here, you might see the term X units sometimes, EX units. I'll write that in the chat just so you can see it. Sometimes you'll see that right there, and that means the same thing as what CPU means. Thank you for managing the agents here, Newman. Very good. All right, let's see.
Oh, yeah, actually my agent can't come in. I'm gonna try one more time.
Oh, really?
Yeah, yeah.
What's needed in order to get that to work?
I don't know. It just says I paste in the Zoom invite. Maybe I've got the wrong invite link. But it says no audio detect. I bet I've got the wrong invite link.
I'm curious about whose Aiken AI note taker is here. Is that anybody here?
Yeah, Ken AI or Kenai.
Yeah. Somebody has a Ken AI account and they assigned it to attend this meeting.
Yeah, which is cool. If you're
Yeah.
reading this, hey, come in and
Yeah.
introduce yourself. We're friendly.
Yep. We find your behavior a tiny bit antisocial, but we understand that you might have a day job. But we do hope that you'll at least identify yourself at some point.
Yeah, yeah, yeah. Even in the Discord sometime.
Yeah, just say what's up. All right. Let's move to the next lesson. So these are like cousins, Datum and Redeemer. You'll always see them, next door to each other. Um, so we're gonna, like it says here, we're gonna explore how Datum works. This needs to be updated. We're gonna use the Datum code example, not the Redeemer one, but this link is correct. We're gonna look at this example in just a moment, but the first thing I want you to know is that remember how I said Redeemer can be thought of as a statement of intent. And the idea that Redeemer is specified at the time a transaction is built. Datum is different than that. Datum is also specified in a transaction. So I need to be a little bit more rigorous in the definition I'm sharing with you. But the critical thing here is that datum is stored on chain in a UTXO. So let's get a little bit better with the definition. Datum is specified at the time of a locking transaction, and it is locked in the UTXO that will later be unlocked according to the rules of the validator. Redeemer is specified at the time of the unlocking transaction. And that's part of why some people like the key metaphor, right? At the time I want to unlock a UTXO from a validator, I share the redeemer as my key or as my statement of intent for why I want to unlock that UTXO. And this makes datum and redeemer a really nice pair because datum specifies the information that we are locking on chain, and redeemer specifies, right, the information that the user of that on-chain information is supplying to make sure that we have a valid transaction. And in this example, we're going to see both of them working together. And this is going to take us a step beyond what we were just looking at, away from just enumerated types and into what Emmanuel referenced a few minutes ago, into some more like robust and realistic types. So I'm going to keep the Redeemer example open right here, just in case we want to go back to it. But let's open up datum as well so we can focus on it. As you can see right here, we are defining custom types for datum and redeemer. We also don't have an underscore right here anymore because datum opt is essential to our validation logic. What does the validation logic say? Well, this is not many lines of code. Here it is, right here, right? But this is a magical example. This is a really, really good example. I didn't write it. Hinson wrote this example. The reason this example is good is because it packs in several really important concepts into one place. Okay. So we're going to go through these one by one. And then, just like in the last example, we're going to play with the tests. We're going to try to break it. We're going to see if we can get failing tests when we expect them and passing tests when we expect them. So a few things to see. First of all, just in plain language, what is this validator doing? It's called check datum. And the reason it's called that is because it's checking whether some secret in the datum is equal to a message in the redeemer. If the secret and the message are the same, this will return true. Otherwise, there's our wild card. It will return false. Where's the true value in this example? I don't see the word true anywhere. Ah, but I do see an arrow pointing to a statement that will be either true or false. So this right here is starting to move us into the place of more robust validation logic. If some, remember where this word came from. Remember I showed you in the documentation, option. What are the values of option? Option can either be none or it can be some of a type. Some of what type? Oh, of datum. Oh, where was datum defined? Up here. We defined it, right? And maybe this is misleading in this example. This is just some custom value, my custom datum, right? It's just an arbitrary name. I could just as well call this foo, right? Foo.
Oh, but don't call it food.
No, we don't like that. Okay. Just to, give you your hello world version, right? But we're defining some datum right here, and datum is optional. It's either some of this custom thing or it's none. Now, if it is some of that custom thing, we're going one step further than that. Look, actually, my custom datum is defined as datum one with, ooh, something else is going on right here. More on that in just a second, or datum two. Notice that the pattern we're matching right here is only looking for datum one. In other words, if datum option is datum two, that's going to fall into the wildcard case and fail. But we go one step. Yeah.
What does some mean there?
Okay. Some means I have some, right?
Okay.
Basically, when I say option, the two
Oh,
the two types of option are I have some of that or none.
huh.
Okay. And that's, again, this is similar to the word maybe in Haskell.
Okay.
Okay. And I love that. Some and maybe are both really like, those words never felt like programming words to me. They feel yeah, but they're very much aligned with their meaning. Do you have some? Yeah, I have some. I have
Yeah.
some datum one. Do you have maybe this? Yeah, and if you use actually the word some aligns with the word just in Haskell, if I'm being more specific. The word maybe aligns with option. So Haskell says maybe, which has the types just or nothing. Maybe you have this. Yeah, I do. I have just this, or I have
Uh-huh.
nothing. Okay.
Okay.
We replace maybe, just, and nothing with option, some, and none.
Okay.
Okay. Do we have some datum? Yeah, I have some datum. But going one step further, datum one is no longer just this enumerated looking thing that we were using in Redeemer over here. And this is very, very important, right? I am not constrained to just the constructor, right? Just the index of some enumerated value right here. I can also provide a statement of intent and a variable. What is the statement of intent right here? I have a message, and this is the message. Go back to the bodega example.
Yes.
All
I was
right.
there. I was already there. I was right
I
there.
I want to buy a coffee and I'm willing to spend $2 on it. I want to buy a
Hmm.
coffee and I want it with cream and sugar,
Yeah.
right?
Yeah.
So often we don't just state our intent, we state our intent and some more arbitrary information. And that's the case right here. I have a message. Here's the message. Oh, and what does the datum say? Well, similar, it says, yeah, I have some datum and it has a secret. And so the validator is just saying, well, does the message that the redeemer is giving us match the secret that's in the datum? And if they match, this will be true and the validator will succeed. And if they don't match, this will be false. And it'll be false in a different way than this is false, right? It'll be false because message is not equal to secret. That's false. Redeemer fails. How's everybody feeling? Can you see how the sky's the limit once you know this? Now you now know enough to start screwing around a little bit. Andrew, what do you think?
Yeah, I'm good with it. I was just about to ask a quick question. So obviously you wouldn't do this, but how are you specifying it that you could hard code, say, the secret as a string as well? Is that possible? Not that
100%.
you would actually do it, but
Okay, well, so let me give you a preview of the next lesson. That's what parameters are for. Okay. Parameters allow us to hard code into a validator some values. Look
okay.
at the first validator, right? We just had a validator named check redeemer. And the second one right here, we had a validator named check datum. Neither of these have parentheses next to them, but this one does. So validator always succeeds. We can add parentheses and then inside of them pass hard-coded values. And this is, for example, where if you wanted to hard code a secret into your validator, it would take on this form. And you could just do it like this, right? You could say, whoops, secret. And we would give it a type, byte array. And there you go. This is how you would hard code the secret. And then if you wanted to use it, we could maybe make this underscore datum ops so we can ignore that now. And we could just be checking if message equals secret like this.
Okay.
Okay.
Cheers. Thanks.
Mhm.
So in the bodega metaphor, this would be like not a full bodega, but just a coffee stand. If the message is you want to buy a coffee, it's like the secret would be $2 coffee. And so if somebody came with the datum message that said $2 coffee, it would succeed. But perhaps if they said, I want a chai tea, fail. If I want a dollar coffee, also fail.
Right. Yeah, exactly.
Yeah.
I want a Gatorade, fail. I want a coffee and I'm willing to spend $1, fail.
Right. Right. Yeah, the sky is the limit.
And technically, we don't have to pass like the datum to anyway, right? Because it falls into the other category that fails, right?
Which, well,
The
like
datum
this.
two.
Yeah,
Yeah,
exactly.
even if you don't pass that, it'll still be the same, right? The validator.
Yeah, why is there a datum 1 and a datum 2 there?
Just to show as an example what Harsh is talking about. Yeah, right.
Right.
Like so now let's look at the tests to make this make more sense. And if anybody has questions about the logic itself, let's go back to this. I do want to point this part out in just a second, but for now, let's look at some of these tests, right? Let's run them all just so we do. Let's do that first. So I'm just going to do MD201L2 to see, okay, first of all three of these tests are passing. So far, so good. Second of all, notice that there's just more lines of code in this file. So it follows that the mem values are higher and the CPU values are higher. That's not the only reason, right? You can see that all these are different mem and CPU values, and there's a reason for that as well. But just broad strokes for just a moment, I hope you see that it makes sense. The longer your Aiken code, the more expensive it's going to be to run it. All of these are passing for now. Fine. Let's look at them and see if we can make them fail or change the context a little bit. First of all, if we let datum be some datum one with a secret and we let the redeemer be the redeemer with its message, and this is the same as this, of course, do you expect the validator to pass? I hope so. What does the next one say? The next one looks exactly the same. It's just that the messages do not match. So we expect this to fail. The reason it passes right here is because we tell it that we expect it to fail, not false. Oh, that's going to be true. And then finally, same thing here. If you pass datum 2, it actually doesn't matter what this is. There's nothing to compare it to, but we're not even going to get to that comparison logic because this case right here is only covering datum 1. False. However,
Okay.
what if I did some
Yeah,
datum
there you go.
2,
Yeah.
right? And I made that return true. That be okay? Oops. Now I would expect the third test to fail. Whoops. Try that one more time. Sorry. Sure enough. Okay. Remember as well that we have the ability to get a little bit more like of a verbose response on this failure. And where was that? We looked at, oh, the question mark. Yeah, that's what I wanted to pull up. If I put a question mark on this test and I run it again, I should get a more verbose. No, that didn't work. Oh, that's because I'm in datum. No. I want to put that question mark down. Oh, no, I'm in the right spot. It didn't give me a verbose response. I'm going to troubleshoot that later. I'm not sure why. But in any case, if I remove the exclamation point, now that we have datum 2 is true, I would expect this to be true no matter what,
Right. Okay.
right? The message is actually irrelevant if we're using datum 2. Thoughts? Is there anything anybody wants me to try with either the datum type, the redeemer, or the logic right here, just to see if do you have any hypotheses that you want to test that we can try out together?
Hmm.
Sorry, just a quick one, just on that final test. So what's passing and what's failing there at the moment? Is the final okay? Would you
This
expect the
one, right?
final test to pass?
Yeah. Only because I added this line right here, right? If I add to the validator the line that if I have datum 2, just return true no matter what.
Mhm. So then down at the test,
Would it not need to be or? Or
Oh,
am I
oh, but
misreading
like,
that?
yes, but we're typically not going to use or in this pattern right here. This is more of a functional programming pattern matching pattern, and it it's a little bit unreliable to try using or in these scenarios. We want as much determinism and certainty as we can, and or introduces a level of uncertainty that in most cases is going to be frowned upon when you're writing a validator.
Okay.
So, right. So instead, we explicitly define, okay, if this is the case, here's how we're going to cover it. And if this is the case, here's how we're going to cover it. And for all other cases, return false. Do you feel how, like in a financial system, that's a better approach?
Uh, yeah, sorry, I'm just working around my head. I'm misreading it, but ultimately that's saying either. Is that right? So it's saying if either of those
Yeah.
options are true,
Yeah.
then
If
it passes.
okay. And it doesn't evaluate all of them though. It says, okay, first of all, look at the datum. Hey, when you looked at that datum, did you find datum one? If so, keep going. If not, if the datum is not datum one, it's going to pass right over this. And then it's going to say, well, is the datum datum two? Okay, if so, execute this logic. And if not, keep going. Right. So
Right.
ultimately, it's like either this or this, right? If either this or this is true, return true. But the way it's structured is that we are looking at each of those cases in a very specific and targeted way.
Okay. Yeah. It's almost like it's running a loop to find the if anything matches, then if not, false. I get it.
Yeah, run through, go look at the datum, go through each of these possibilities. If the datum satisfies one of these cases, do that logic. And another thing that actually might be misleading about this example is often the logic right here is going to be many lines long, right? I can, okay, so if the datum is datum one and it has some secret, open up some new curly brackets, and we can have an arbitrary amount of logic right here. And if you look at, production level validators, you're going to find a bunch of stuff going on in each of these code blocks, right? And for me, that's sometimes seeing a simple example doesn't tell me the whole story. I need to see like the full story to like wrap my head around it. So hopefully that helps to kind of imagine it that way, that we have all of this arbitrary logic that ultimately leads to some Boolean statement.
Okay. Okay, thanks.
Mhm. Let's do one more thing. Instead of opening up this example, I'm going to save this. And what I'd like to do right now is make this example feel like a review when we reconvene next week. And the way I'd like to do that is by giving you a preview of how parameters can be used by adding them to this example right here. Watch this. Let's say that datum 2 also has some secret. And because these are different cases, there's not going to be a name collision right here. Datum 1 has a secret. Datum 2 has a secret. If you're familiar with JavaScript or TypeScript, datum 1.secret, datum 2.secret. Those are different values. Let's also go ahead and add a parameter right here. And what can we do here? Let's make it the some embedded message. Okay. And we're going to make that a byte array. So we're going to have a hard-coded embedded message, and we're going to have a different message that can be passed by the redeemer. We're going to have two different datums. And all I want to do here is say, well, keep this logic. If we have datum 1 and a secret, check that the message and the secret match. If I have datum 2, let's do the same setup, but let's check whether or not, in this case, the embedded message equals secret. See how that works? And I think the camel case right here it's unhappy about that. Um, I'm just going to change this to embed MSG for now. What's that? Okay. But just in terms of the concept I'm showing you, any questions about the distinction right here? Now, there are reasons why this example is actually a little bit silly. And without going too into the weeds, I don't want to overwhelm people, but actually, this case right here would ultimately turn into an always succeeds or an always fails scenario. The reason being that the embedded message is going to be part of the validator at compile time. And the secret being in the datum, it needs to be posted on chain. So basically, the result of this case right here is going to be preordained at the time a UTXO is locked. But setting that part aside, we can still look at this example just to kind of see how the logic works. And it might be better if instead of providing two datums, we provided two redeemers. If everything I just said makes sense to you, congratulations, go play with those ideas. If I lost you right there, don't worry about it too much. My goal right here is just to help you play with some of these possibilities. Okay. And in order to play with them, let's look at the tests, right? Okay. Now, because I didn't update these tests yet, of course, I think test number 3 is actually going to break. Let's just see if that's true. And what I just said there is uh, I could not recommend that habit of mind more, right? I think when I run these tests, this is going to happen. Please say that to yourself when you're writing your own tests, right? Before you press the button, make a prediction in your head about what you think is going to happen. So I think I'm not going to see 3 nice, clean test results. I think I'm actually going to see like a compilation error from Aiken when I run this. And I do, right? Why do I see this? Well, it's because I didn't properly format things on line 41. Yeah, exactly. Um, oh no, that's not where the problem is though. Missing fields. Oh, that's because right, when I run this test, I need to provide the parameters. Let's look at this test down here. Right. Succeeds as the UTXO. All right, this is a little bit beyond what we can reasonably do in the next 3 minutes getting this part right. So actually, let's pause here, but we can pick it up here next week. That'll be fun. And so the reason this doesn't work is I need to add to the tests this parameter, but I need to review my other notes personally to remember precisely how to do that. And I would love to do that live and in person, but we are just about at time. So I think that's pretty good for today. There are 7 lessons in Module 201. We got through the first 2 today, but we covered a lot of background knowledge along the way. And I'm thrilled if it takes us a couple weeks to go through Module 201, because I think this is the most important one in the course. This is the module where you are learning about the essential tools of Aiken or any on-chain development. We started with Redeemer. We just looked at datum. I was trying to show you a couple things about parameters, but we're going to pick up there next week. And then we're going to look at a few of the finer details. We're going to look at validating against inputs, validating against signatures, validating against time, and then validation based on comparisons between input and output. That's all coming. It took us like a little more than a half hour to do each of these lessons today. And I think it's worth it to budget about the same for the next 5 lessons as well. So I'll bring those updates to Hinson. He's going to be our lecturer next week. So that'll be fun, and we'll see what happens. Thanks everybody for spending time today. And yeah, you only have to do that first lesson of the year once. So I'm glad that one's out of the way. Here we are.
I got
All
a
right.
question about
That's great.
about the cost again. So those are that's pushed against the Plutus V3 parameter cost?
Correct. Yeah. So
Okay.
at the hard fork, the cost parameters, like the price per X unit, the price per memory, was tweaked a little bit. And so that's why the exact same contracts might have a slightly different cost post hard fork.
Gotcha. All right. Thank you.
And now, I mean, in a couple months after the hard fork, right, we're going to be able to vote on changes to that. We could vote to make like memory really, really expensive. What's going to happen? Who knows? All right, everybody. Thanks for hanging out today. See you soon.
Thanks.
Bye.
Hey, James, real
Yeah.
quick. Hey, when are we going to, this is aside from Aiken, when are we going to discuss the DREP issue situation?
It's only a situation if you say it is, right? But on Thursday, we're gonna build a primary driver for Gimbalabs. We're gonna do a two-part workshop this Thursday and next. If anybody here wants Gimbalabs to treat DREPs differently, their responsibility will be to write a proposal for that and for us to go about it. Yeah.
Gotcha. Yeah, I
Yeah.
was just talking to Steve over Discord, and so
Yeah, let's make sure to use the process, right? So if anybody has any objections to Gimbalabs being a DREP, they can write a proposal for that, and if a proposal for Gimbalabs to not be a DREP passes, I'll take it off chain, no problem.
And we did some work on sort of investigating that DREP issue already there's a DREP proposal in the task in our proposal section, in our projects page on the Notion. And Scott, are you a Notion user?
I'm not. I despise that platform.
Well, you can
Guys, I got to jump to the next meeting.
Okay. See you, man.
All right.
Thanks,
Thanks,
James.
James.
Bye.